So this little lecture is going to go through this problem where we're told a solution has a hydroxide concentration of 1.9 times 10 to the negative third molar, and we're asked to calculate the pH, pOH, and concentration of hydronium to go with it. So confronted with a problem like this, we have a few things to calculate. We are given a hydroxide concentration. So the first thing it might be useful to do is to look up the useful equations related to pH. So I'm going to go ahead and punch those in. And here they are. And we can see, if you recall, remember pH is equal to the negative log of the concentration of hydronium. pOH then is equal to the negative log of the concentration of hydroxide. We know Kw is equal to the product of hydronium and hydroxide. And also the pKw is equal to 14, which is equal to the sum of the pH and the pOH. So we can now use these equations to solve for the various things we're asked for. There's a number of ways you can go about this. I'm going to choose to go first and calculate the pOH. And so pOH is equal to the negative log of the concentration of hydroxide. So we can go ahead and put that in, say pOH is equal to the negative log, and we're given that hydroxide concentration, 1.9 times 10 to the negative third. Plug that into our calculator, and we get the pOH to be 2.7. So there's our first one. Again, we can go in a bunch of different directions. I'm going to actually go through and say, let's calculate our pH next. And to find the pH, I'm going to use the formula where 14 is equal to the pH plus the pOH. So our pH is equal to 14 minus the pOH, which we just found was 2.7. So our pH is now equal to 11.3. So now we have the pH, and we can see this is a basic solution. And so finally, we're left to find the concentration of hydronium. We could do this a couple different ways. We could use the Kw expression, because we know Kw and we know hydroxide. Or we could use our pH expression, which I'm going to choose to use the pH, but both will get you to the same point. So pH equals negative log of the concentration of hydronium. And so we want to solve for that concentration of hydronium. And so we actually have to get rid of a log function. And so to do this stepwise, I'm going to move the negative sign. Get negative pH is equal to log of the concentration of hydronium. And to get rid of that log, if you recall, we would need to do 10 to the raised to whatever's there. So 10 to the log of x is just equal to x. And so if we do 10 to the negative pH, that's going to be equal to the concentration of hydronium. So 10 to the negative 11.3 equals 5.0 times 10 to the negative 12th molar. And there is the concentration of hydronium. Thank you.